Okay, let's take a look at this worksheet for section 3.5. So we want to determine if 6, 8, the point 3, -4, and the point 3, 4 are solutions to this inequality 2x minus 1 greater than 5. And the way that we do that and justify our answer is to substitute 6 for x and 8 for y for the first point in the inequality. So we're going to replace x with 6 and y with 8. We're going to see if what results is true or not.
Yeah, and then
All right, so 2 times 6 is 12. 12 minus 8 greater than 5 winds up being the statement 4 greater than 5, which is false. All right, so that allows me to conclude that 6, 8, that this point 6, 8 is not a solution. To the inequality. All right, and the work is as simple as that. I test each point in the inequality to see if the statement that results is true or false. All right, let's test and see if 2 times 3 minus -4 is greater than 5. So that's 6 minus a -4 is the same as adding a +4. So I get 6 plus 4 greater than 5. And obviously 10 is greater than 5. So that statement that results when I let x equal 3 and y equal -4 is true. So 3 -4 is a solution to the inequality. All right, and let's try this third point, 3, 4. So 2 times 3 minus 4 greater than 5 becomes 6 minus 4 greater than 5, which gives me the statement that 2 is greater than 5, which we know is false. So that basically allows me to conclude that 3, 4 is not a solution to the inequality. Okay, so similarly, we're going to use this same method on number 2. We want to know if 8 -2 is a solution to 4x plus 3y less than or equal to 24. So we are going to replace 8 with x, or x with 8, and y with -2. So we get 32 minus 6 less than or equal to 24, which gives 26 is less than or equal to 24, which we know is a false statement. So the fact that substituting x, 8 for x, and negative 2 for y gives us a false statement means that this point, 8, negative 2, is not a solution to the inequality. All right, let's check negative 5, 10. 4 times negative 5 plus 3 times 10 less than or equal to 24 gives me negative 20 plus 30 less than or equal to 24, which gives me 10 less than or equal to 24, which is a true statement. So it is true that 10 is less than 24. So the statement 10 less than or equal to 24 is therefore true. So negative 5, 10 is a solution to the inequality. And now let's test the point 3, 4. Let's see if 4 times 3 plus 3 times 4, so we're replacing x with 3 and y with 4. Let's see if that's less than or equal to 24. So we get 12 plus 12 less than or equal to 24. 24 less than or equal to 24. So since 24 is equal to 24, the statement 24 less than or equal to 24 is true. So the point 3, 4 is a solution to the inequality. All right, let's take a look at graphing an inequality that has two variables in it. So 3x plus y less than or equal to 2 involves the equals in the inequality. So if the inequality is a less than or an equal, a less than equal to, or a greater than or equal to, we're going to plot the line. So we're going to plot or graph 3x plus y equals 2 as a solid line. So whenever the inequality symbol has the equals with it, so that means if I have a less than or equal to, or if I have a greater than or equal to, I graph the line as a solid line, because points on the line are solutions to the inequality. All right, so we want to graph this line. And you can do this in whatever way you would like. You can put this in slope-intercept form. If I do that, I subtract 3x from both sides in order to get the slope-intercept form. Or you could graph this by plotting points. So I have y equals negative 3x, sorry. Plus 2. So I plot the y-intercept 0, 2. This constant gives me the y-coordinate of the y-intercept. And then I use the slope to move from this y-intercept to another point on the graph. And since the slope is negative 3, I'm going to look at that as negative 3 over 1. So from the y-intercept, I'm going to go 3 units down and then 1 unit right, and that will put me at another point on the graph. So I'm going to plot the point 0, 2, and from that point I'm going to move 1, 2, 3 units down and 1 unit right. And that gives me a second point on the line. Okay, so there's my line, my solid line. And now I need to test, I need to get a test point. So I'm going to test, I can test any point that doesn't lie on the line. I always test the origin because it's so easy to work with the origin. The only time I can't use the origin is if it lies on my line. So 3 times 0 plus 0 is less than or equal to 2. So 3 times 0 plus 0 is simply 0. And that is a true statement. So I want to shade the part of the graph that contains my test point when the test point makes the inequality true. So I'm going to be shading the part of the graph that contains my test point, which was the origin. And so in my math lab, you'll choose the little bucket and go to the region, then click it. Once you select the bucket, go to the region that you want to shade, and it will automatically shade it. So you won't, in my math lab, you won't quite have this much work to do. All right, so I'm shading the region so if the test point represents all the points in this region. So if the test point makes the inequality true, then all the points in this region will make the inequality true. So notice the line divides the plane up into 2 regions. So one region, everything in this portion of the graph makes the inequality false. Everything in the region I've shaded makes the inequality true. All right, my last problem is the inequality 5x minus 3y greater than 6. So because this inequality does not contain the equal sign, I'm going to graph or plot the line 5x minus 3y equals 6 as a dashed line. And that's because points on the line, when there's no equals to in the inequality, make the inequality false. So I'm going to take this equation and I'm going to put it in slope-intercept form. I'm going to subtract 5x from both sides. So I get negative 3y equals negative 5x plus 6. And now I'm going to divide every term by negative 3. And so I get y equals 5/3 x minus 2. All right, so I'm going to plot my y-intercept, which is 0, negative 2. The constant in this equation gives me the y-coordinate of the y-intercept. So here's 0, negative 2. I plot that. And now I'm going to use the slope to move from the y-intercept to another point on the graph. So my slope, which we call m, is 5/3. So I'm going to move 5 units up from this point, 0, negative 2, and 3 units right. So from this point, I move 1, 2, 3, 4, 5 units up, and 1, 2, 3 units to the right. And now I'm going to draw a dashed line. Okay, so there's my dashed line, and I now want to do a test. And since the origin doesn't lie on the line, I'm going to test 0, 0. That's always the easiest point to test. Only time you cannot use it is if it lies on the line. All right, so we'll see what 0, 0 does. So 5 times 0 minus 3 times 0 greater than 6. So this whole left side merely becomes 0 greater than 6. So that's false. So what that tells me is my test point and all the points in its region, in the same region as the test point, make the inequality false. So I am going to shade the region that doesn't contain my test point, since my test point made the inequality false. So notice points on the line and all points in the unshaded region make the inequality false. So this would be the graph of this solution set.